Right, now we're going to learn about phase difference between two particles on the same wave and also the phase difference between two separate waves lah. So what is the difference between the phase difference between two particles on the same wave and the phase difference between two waves? Now first let's talk about the phase difference between two particles on the same wave. Now remember we were saying that if all of you were in the stadium doing the Mexican wave, so let's say this is the first one person here, this OP, QRS are different people, right? Which are what we're going to say the people making the Mexican wave in the stadium. Now how you do the Mexican wave is, let's say this guy starts to move, then this guy must delay a little bit, then this guy must delay a little bit before they start, right now. They cannot start at the same time, remember? So what will happen is, this guy will start first, let's say, and this guy will delay, will start a bit later, then this one a bit later, a bit later, a bit later. So when you say you start a bit later, right, then we can say how much later, correct? So how much later this guy starts after this guy, we can measure it in what we call as phase difference. And phase difference must only be measured in terms of degrees or radians. So before we convert into degrees and radians, we need to know how far apart are these particles. Then we can figure out how many degrees and radians. For example, let's look at this 1, 2, 3, 4, 5 particles here. Now, which two particles would you say are moving in phase? That means which you see always moving together. Which of these two particles are always moving together? So if you examine, you will notice that O and S are always moving together, because when O goes down, S also goes down. Then when O goes back up to the middle, S also goes back up to the middle, all right? So therefore, O and S are in phase because they are always at the same point and they're moving in the same direction. So that is called in phase. Now, if you look at O and P, O goes down, P also goes down. But when O goes back up to the middle, P continues to go down. So there's a slight phase difference. That means they're not together. Phase difference means they're not moving together. But how far are they apart? Okay, we're going to measure it. But if you compare O and Q, there's bigger phase difference. Because when O goes down, Q goes up, the opposite. So there's a bigger phase difference now. So we know there are phase difference between OP, OQ, OR, but OS are in phase. So how do we measure the phase difference between OP? So the technique is always find the distance between them in the context of one wave. So what is this distance called? If from O to S, what is this distance called? The wavelength. So if this is the wavelength, O and P is how many wavelengths? 1/4 wavelengths. So if it is 1/4 wavelengths, then how do I convert to degrees or radians? All right, I'm going to show you now. So when you want to measure the phase difference, you need to convert all these wavelengths, all right, the distance between them into degrees or radians. So how do you do that? Now, do you realize one complete cycle, like this wavelength, is actually equivalent to 360 degrees or 2 pi radians. So that means if you want to convert your wavelength, so remember our first step, find out how far are they apart in terms of wavelength. So this is 1/4 of a wavelength. Since one wavelength is 360 degrees, so you get 90 degrees. Or if one wavelength is 2 pi radians, then it's pi over 2 radians. That's how you convert. Example, another example, between O and Q, how many wavelengths are they apart? Half a wavelength, right? So a half wavelength, if I convert to degrees, how many degrees would it be? 180, yes. And how many radians? Pi radians. Okay, so that's how you convert. You can substitute the lambda as 360 degrees, so divided by 2 is 180, or you substitute the lambda as 2 pi radians, divided by 2 is pi radians. So that's how you calculate the phase difference between two particles on the same wave. It means you got to find the wavelength first. How far apart are they? All right, and then only convert. Okay. So now we're going to talk about phase difference between two separate waves. So what do you mean by phase difference between two separate waves? Let's say you go to the stadium and because there are two teams competing, let's say the supporters for one team start their wave first, and then the supporters for the second team start to get jealous and then they start their own wave. Because they started a bit later, there'll be a phase difference between the two waves. You understand now? So just now we talk about two particles within the same wave. That means two supporters of the same team in the same wave. But this is two different waves. Two different separate waves. So how to find the phase difference between two waves? It's the same technique. If let's say you see this red color wave and the blue color wave, you find, right, the point that is the same for both. Let's say you take the peak for this red color wave, then you take the peak for the blue color wave. How far apart are they? Also in terms of wavelength first. So you imagine, even though this is like in radians or time or whatever, you don't care. You just assume like this is one wave. Alright, this is one wave. So between here and here, how many wavelengths are they apart? So if the red color wave is here, blue color wave is here, this is one wavelength. So if they're separated by this distance, how many wavelength is this? 1/4 wavelength, right? Can you see that this is one cycle? So this is like one wave. This is one wave. From here to here is about a quarter of a wave. So from λ/4, then you get 90 degrees, or pi/2 radians. Do the same thing. Alright? So now, the next thing I'll teach you is which wave is leading which wave. That means, how do I know which wave started first? So which wave do you think is leading which wave? That means, is the red color wave leading the blue color wave, or is the blue color wave leading the red color wave? It's actually red leading blue. But many people think it's the blue leading the red because it's on this side ahead. But you must remember, most of the graph is in terms of time. The t-axis here. So on the t-axis, who starts first will be the one that's leading, right? So you look at the t-axis, the red color starts first. So it means if you take this as the reference point, that means you assume that this is the starting, this is the starting. So red starts first. So therefore, red is considered to lead the blue, or you can say blue is lagging the red. Okay?